Shahama got a different answer. Hmm. Check your simplification a little. I think Amna also got 3 amperes and simple IS 2.5. Now you got simple IS 2.5. Shama, just check a little. Now that is not your final answer, okay? That is not your final answer. We have to find the current through each resistor. So across 2 ohm, that is capital I. Therefore, it's 3 ampere. No problem. Next, across 4 ohm, it is simple I. So that is also okay, 2.5. But across 8 ohm, that is I minus I, that is the current. So across 8 ohm, that is 0.5. Okay, so here the potential, this is current, and what is the potential drop? Here it's 6 volts. Here this is 10 volt. Just multiply, and this is 4 volt. Here, how I got these answers? I'm okay, and I'm not. Both of you. Shama, you can check the simplification later if you haven't figured it out yet. Okay, so that's example number 7. Example 8. So current through each resistor. Just think and first mark the current. First mark the current in the branches, and then you can find. Here, can I tell the current in this is 2I and current here is I. Now I see two resistors that are in ratio. So can I tell like this? This is 2I and this is I. Is it correct or incorrect? Correct or wrong? Saham, what you say? Saham, any idea? Can't. Here, when do we use current divider? Current divider is when we have two, you have two resistors connected in parallel. Okay, these two resistors are not in parallel because we have a battery here. If we don't have a battery or any other component over there, then it is in parallel and you can apply that. Okay, so Amna, you clear that we cannot apply. Both of you, have you all got these two equations? Okay, so solve. Solve. Got these answers? Capital I and simple I. Uh-huh. Okay, right? So how is it applying the rule? Is it hard or easy? Not that hard, right? If you understand the concept easily. Find the current through R. So when you mark, analyze the circuit, okay? Analyze the circuit, understand and mark. So here, what can you tell about the EMF? Both of them have equal EMF. Therefore, does this battery have enough power? Does it have enough energy to push current into the upper circuit? Or, so that is first case, okay? The battery below will push current to the upper circuit. Or another possibility is both of them push current down and that current will flow through this. So that is case 2. Which one is possible? Case 1 or case 2? Which one is practical? First or second? Yeah, so Shahman, can you continue and find what is I? I'm not using. Which one is more practical? The first one or the second one? Okay, Amna, I'll again tell you the possibility. Now, both of them are having equal EMF. Okay, both of them, it is just like both of them have equal power. So, I'll say the battery, the upper battery, the lower battery is sending current I. Okay, now if this was 10 volt, if this was 10 volt and this one was 8 volt, then obviously the 10 volt is going to win and it can push some current into this circuit. But if both of them are having equal power, then the lower circuit is not having enough power to push current into the upper circuit, right? Because the upper circuit also will be putting the same effort. Therefore, the current, both the current has to go through this. Did you get me, Amna? So Second one is practical, right? Than the first one. Now, can you find the current through R? Got this answer. Find V1, V2, V3. The resistance are not given. So you can consider loops, and using the KVL, you should be able to straight away find what is V1, V2, V3. Found? So here, finding V3 is the easiest. Consider this loop. I'll number these loops. 1, this loop as 2, and this loop as 3. So considering loop 1, what can you tell? Here you have what is the total EMF in this loop? 10. I mean total potential rise is 10. And what is the drop? Only V3. Therefore, V3 is equal to 10. Is that clear? Here mark the arrow, otherwise it will confuse. Mark the potential drop. Here you have potential rise. Here you have potential drop. Is that clear? Similarly, can you find V2 and V1? What is V2? Um, what is V2? Here you have a potential increase. Here also you have a potential increase. Here only you have potential drop. Therefore, 12 plus 10, 22. So V2 is 22. Is that clear? Rahama, is it clear? Right, next one. Example 11. So think about this circuit, look at this circuit, think about the symmetry, and after that mark the current. Okay. What can you tell about this circuit? About the center, it is symmetric, right? So how will the current divide? Will they divide equally or at certain ratio? split to divide equal. Got this answer? Anna? We'll try one more example, and after that, go through the past paper questions. So here you have to find I1, I2, and I3. But here we have already marked the current, so you just don't bother about that. If you want, redraw the circuit and mark in your convenient way. Okay? So we get questions like this. They give I1, I2, and I3, and they ask to find. So if you're not convenient with this, just redraw the circuit and mark the current. Okay? So we have that I1, I2, I3. I erase them to do the question. Okay? So I will mark in my convenient way and do the question. This was I2, right? I minus simple I. What does this minus 0.75 mean? What does minus 0.75 mean? It shows it is in the opposite direction, okay? This is current. I have marked the current towards my right, like this. I have marked in this direction. But if I get negative, it means the current is going from C to B, not B to C, okay? I'm not clear. And Shahama? Uh, Amna, we don't say drop in current. We used to say drop in voltage, rise in voltage, okay? We only talk about direction for current. Okay, Amna, here we have got the current, okay? We have found the current. Therefore, when we have negative current, it is not voltage, right? Your idea is correct. If we had voltage, if we had negative voltage, that means it is a drop, okay? It might change. Don't get confused with that. Here, let's say, no, we cannot directly say that because now, let's say the arrow is marked like this, 2 volt, okay? Arrow is marked like this. Now, if you are talking about voltage drop, and when you're moving in this direction, okay, it will be 2 volt, okay? So it will be positive 2 because you are talking about voltage drop. But if we talk about voltage rise, then it will be minus 2. Okay, so just without these two words, without voltage drop or voltage rise, we cannot tell plus and minus sign. Using plus and minus and just the word voltage, we cannot tell whether the voltage is increasing or decreasing. Did you get the idea, Amna? Because we can either have voltage drop or voltage rise. Therefore, plus and minus doesn't have a proper meaning. Okay. So that's all for today. I will post some question in the group from the past papers. Try those questions. Those questions are not tough as the questions we discussed today. It will be a little easier. Okay. So if we finish Kirchhoff law under electricity, that is related to electricity without electromagnetic induction, we only have the practicals. Okay. Assalamu alaikum. Let's meet in the next session.